Good morning, scholars. Happy Monday. I hope everyone had a fantastic weekend. I was incredibly impressed with the math work you did on Friday, both the amount of scholars who got a 100% and the amount of scholars who had their work turned in on time with no reminders. Can't wait to do 100% shout outs in just 1 second. As a reminder, Monday is a great time to check your grades by logging into your classroom, by going to view my work to see if you have any missing assignments. Many of you do not have any missing assignments, which is a great time to check those grades and see how you're doing in class. So let's kick it off with some shout outs this morning. Long list today. We had 24 scholars score 100%. Representing from UNC, we have Chris, Miguel Angel, Manuel, Lyric, Anaya, Dillery, Annalie, and Tenbeat. Phenomenal work. From SCU, as usual, our longest list. We have Jakira, Adam, Amelia, Anira, Nevea, Ricardo, Aiden, Danya, and Philip. Huge shout out to those SCU scholars. And representing from Duke, 100% from Edwin, Larry, Monica, Yasmin, Camila, and Dame. Really nice work. I was stoked to see so many 100%, and again, so excited to see just the responsibility and initiative of so many scholars who were coming to office hours on Friday, who were coming to reteach on Friday, scholars who got their work submitted on time, and the amount of scholars who have every single assignment turned in so far. Really nice work. Today's math is going to look just a little bit different. Today, we are going to be reviewing both multiplying and dividing decimals. We're going to do some problems together, then you're going to have some to try on your own. And your independent practice today is actually just going to be entering the answers from the work we're doing together. So it should see nothing but 100% as long as you're following along with the video, doing the math on your own paper. You are guaranteed to get every single question correct. Before we dive into that math, let's take a look at just two charts, and I'll be referring to these a lot as we go. It's been a while since we've been multiplying decimals. We've been working for the last week and a half on dividing decimals. So let's just remind ourselves, when we're multiplying decimals, what are some strategies we can use? Now, this is not the only strategy you can use, but after we practiced many strategies such as repeated addition, such as turning our decimals into fractions, such as partial products, many of us decided that really multiplying using the standard algorithm was the most efficient way of multiplying our decimals. So that's the strategy we're going to review today. Remember that step one, you line up the numbers from right to left, just like you would with any standard algorithm. I'm not worried about lining up the decimals. For example, if I were to multiply 12 and 71/100 times 4/10, unlike addition, I don't need to multiply, or I don't need to line up my 4/10 with the 7/10. I'm just going to line up my numbers just like I would for any standard algorithm. Most of us are at a point now where we're comfortable leaving the decimals in there and just kind of ignoring them as we multiply. But if you're a scholar who still likes to rewrite it without the decimals, you're welcome to do that. In step two, we multiply just like normal using that standard algorithm. Here I might get to an answer then of 5,084. Then step three, we did a lot of work with this 2 weeks ago. We would count all the numbers behind the decimal and put the same number of digits behind the decimal in the product. So in this example, we have 1, 2, 3 digits after the decimal place. And so we would move it over 1, 2, 3 places to get an answer of 5 and 84 thousandths. We did just a lot of really great work with multiplying decimals. Excited to review that a little bit today. And then what we've been working on for quite some time is dividing decimals. So when dividing decimals, we remember that the first thing we want to do is create that equivalent expression where we move the decimal to the right as many times as it takes to get the decimal removed or gone. We're not forgetting about it, we're just moving it over. And as long as we move it over an equal amount of times in both our dividend and our divisor, we know we have an equivalent expression. So here we could take our 48 and 40 hundredths divided by 2 hundredths and actually just turn that into 4,840 divided by 2. And then we will divide. Today we're going to take a look at both this strategy and then one other way that you may like to use when dividing decimals. All right, I'll put these charts up to reference as we go, but let's dive right into some practice problems. We do have 5 we're going to do together, and then you have 1, 2, 3, 4, 5 that you're going to be doing on your own, but we'll be checking in after each one, and then these will be the answers to your independent practice today. So again, as long as you're following along with the video, doing all of that work, everyone is guaranteed a 100% because all you're going to do is enter the answers that you've already gotten. All right, let's dive right in. All right, go ahead and set up your scrap paper. I know some of us like to fold it in half. So if you like to do that, go ahead and do that and make sure that you're numbering your problems correctly because you will need to know which problems I'm asking for on your independent practice. So I'm gonna go ahead and label problem number 1. I see that it is a decimal multiplication problem, 59 and 8/10 times 15 hundredths. I'm going to immediately write it on my paper like the standard algorithm because I want to start off using this strategy. So I'm going to line up my decimals. So I'm going to go ahead and rewrite it on my scrap paper, 59 and 8 hundredths times 15 hundredths. And I've already set it up using the standard algorithm. Go ahead and check that yours matches mine. Now, many of us are at a point where we're comfortable just multiplying like this, kind of pretending that decimal isn't there. But if you like to rewrite it, totally getting rid of the decimal, you are welcome to. So if that helps you to rewrite it without the decimal there at all, feel free to do that. Now that we have rewritten it, I remind myself that step 2 is just to multiply like normal. I'm going to leave this chart up. Go ahead and multiply your decimals using that standard algorithm. All right, take 10 more seconds and we'll check in to see what we got as our product when we multiplied using the standard algorithm without the decimals there. All right, I got to an answer of 8,970. If you also got that, thumbs up, way to go. But I know this is not my final answer. If we had estimated, we know this isn't correct. We also know when multiplying using the standard algorithm that since I temporarily took my decimal out, I now need to add them back in. I need to count the amount of digits I have after my decimal point, all of them. So I'm going to count 1, 2, 3. If you already know where the decimal goes in your answer, go ahead and put it in. I'm going to count 1, 2, 3. I'm going to put my decimal point right after that 8. So we should have an answer of 8 And we can either read it as 8 and 970 thousandths or 8 and 97 hundredths. I can drop that 0 if I want. All right, nice work on number 2. I'm number 1. I'm going to draw a line right under that and get set up for problem number 2. All right, problem number 2, we have a decimal division. Let's go ahead and write this on our scrap paper. I'm just going to keep mine horizontally for right now, while I think about some different strategies I might want to use. All right, so I've written my problem on my scrap paper. 2 different strategies we can use that I've seen scholars using when dividing decimals. I want us to try both of them right now, and you might decide that you have a favorite one that you like to use. One of the strategies we've been working on is creating those equivalent expressions where we remove the decimal points. So in order to do this, I would move my decimal point over 1, 2 places in my dividend, which means I would need to move it over 1, 2 places in my divisor. I would fill in those holes with 0, so I'm going to rewrite my division equation as 1,876 divided by 400. All right, now let's go ahead and solve. We'll go ahead and divide. Let's use our big 7. All right, do this along with me as we're dividing. So I'm starting off with 400. Asking myself how many times does 400 go into 1,876? Well, I can do 400. Let's see if I do 400 times 4. 4 times 4 is 16 with those 2 zeros. So if I multiply 400 times 4, that gives me a product of 1,600. And I'll go ahead and subtract. All right, now I'm at a place where I'm thinking, well, 400 does not go into 276. 400 is too big. But I'm not just going to leave this whole thing as my remainder, because as I look at my answer choices, I don't have anything with the remainder. So instead, I need to figure out, well, what can I multiply 400 by? It's got to be something smaller than 1. That would get me to a number around 276. And one thing that I think about is, well, if this number were just 4, and I wanted to know how many times does 4 go into 276, one multiplication fact that I know right away is that 4, I know 4 goes into 200. So I know 4 times 50 would be 200, but I don't have 4. I have 400, but 400 times 5/10, I could also think of that as 400 times 1/2. Half of 400 is 200. I also know 4 times 5 is 20, so if I move that decimal over, 400 times 5/10 will give me 200. And I can subtract. And I'm left with 76. Again, 400 is not going to fit into 76. It's too big. But I can think of a decimal. I can think of this as 4. How many times does 4 go into 76? Well, I don't know that right off the top of my head, but I do know that I can multiply 4 by 10 to give me 40, which is over halfway there. Instead of multiplying by 10, though, I'm going to multiply by 1/10. So 400 times 1/10 would be 40. I can go ahead and subtract. I'm left with 36. Again, I can think of this as kind of a 4. How many times does 4 go into 36? Well, 4 goes into 36 9 times. But we have 400. I have those 2 extra zeros, so I need to move my decimal over 2 places. And so 4 times 900ths is 36. And when I subtract, I'm left with 0. It worked out perfectly. So now we can add up our 4. I know 5/10 plus 1/10 is going to be 6/10. 6/10 plus 900ths is going to be 6900ths. So we can write our final answer as 4 6900ths. Let's just check. That is one of my choices. Also, if I estimate, if I say this is around 18 divided by 4, well, I know 4 times 4 is 16. It's going to be a little bit more than 4. 469 is definitely way too big. 53 is too big. Even 46 is too big. So this is definitely my best choice. Now, I want to show one other way that you can solve this if you don't like having to divide a bigger number into a smaller number with decimals. I'm going to do my other way right next to it. So I'm just going to label this as also question number 2 right here. I want you to work this one out along with me as well. This is a strategy. You may like this one a little bit better. I have seen scholars doing both of these. So one other way I could think about this, remember our original problem was 18 7600ths divided by 4. Now, because I already have a whole number in my divisor right here without a decimal, just like with my multiplication, I could actually just divide 4 into 1,876. Just like with multiplication, kind of ignore that decimal point for right now, and then add it back in at the end. In my first strategy, I didn't have to add a decimal back in because I'd already created an equivalent expression. 1,876 divided by 400 is exactly the same as 18 7600ths divided by 400. But watch what I'm going to do right here. I'm going to set up the same division problem. Just like with multiplication, I am just temporarily taking out that decimal. I'm going to think of this as 1,876 divided by 4, and then I will have to remember to add my decimals back in, just like we did with the multiplication. So now I can go ahead and multiply. So I know 4 times 400 would get me to 1,600. When I subtract, I'm left with 276. 4 times 50 gets me to 200. And when I subtract, I'm left with 76. 4 times, let's see, I don't know right off the top of my head how many times 4 goes into 76. So I'm just going to do 4 times 10 is 40. And when I subtract, I'm left with 36. And then I'm going to do 4 times 9 is 36. And when I subtract, I'm left with 0. Notice in these two strategies, everything inside the big 7 is actually exactly the same. But notice that my values outside of the 7 are different. Here I was multiplying 400. So my numbers are a little bit smaller, even including some decimals. In this strategy, I was multiplying just by 4. So my numbers are a little bit bigger. Let's see what happens when we add them all up. I add all these up. I have 400 plus 50 plus 10 is 460, plus 9 is 469. However, I cannot leave my answer as 469 because I pretended just for a second that I didn't have any decimals here. Just like with multiplication, I temporarily took them out. So I do need to add them back in. Just like with multiplication, if we go back to our very first problem we started with this morning, we pretended the decimals weren't there, and then we added in 1 decimal for every digit we had after the decimal point. 1, 2, 3. So we added 1, 2, 3 digits after the decimal point in our final problem. I'm going to do the same thing here with my division. Because I took out 1, 2 decimal points, I'm going to put back in 1, 2 decimal points. I'm going to put my decimal point right after that number 4. Notice I got to the same final answer for my division. 18 and 76 divided by 4 is 4 and 69 hundredths. That makes sense with our estimation. We already checked that. The reason that in this second strategy, I needed to move the decimal point once I got my final answer was because I didn't create an equivalent expression. I just pretended the decimal wasn't there. So when I got to my final answer, I had to put it back in. In our first example, I didn't have to move this decimal point because I wasn't pretending it wasn't there. I was actually just dividing using an expression that was already equivalent. Little bit of new information there. We're going to try a few more. You can decide which one you prefer. Do you prefer getting to divide and multiply up with just whole numbers and then add the decimal at the end? Or do you prefer to create that equivalent expression and then multiply by decimals? Totally up to you. Either way, if we go back and check, we got to an answer of 4 and 69 hundredths. So our correct answer for number 2 would be the letter D. All right, let's take a look at problem number 3. Word problem. Go ahead and set up your paper for number 3. David weeds lawns in his neighborhood to earn money to buy video games. For each lawn, he charges $11.50. If he weeds 4.5 or 4 5/10 lawns on Saturday, how much money will he earn? All right, with any word problem, first thing I need to do is write my number sentence that matches the story. So I'm thinking, okay, if David, he's weeding 4 5/10 lawns, for every lawn he weeds, he gets $11.50. So I'm picturing the 4 lawns that the 4.5 lawns that he is weeding. Each one, he's earning that $11.50. And I can tell this is going to be multiplication. And so on my scrap paper, I'm going to go ahead and set up an equation to match the story. And knowing that I have multiplication of decimals, I'm going to go ahead and set it up using my standard algorithm. There you go. Go ahead and set up your scrap paper. All right, let's check in. I have set mine up just like this, remembering that it's not important that I line up my decimal points. I just want to line up my numbers. Many of us can multiply just like this, but if you like that step of physically removing them to look at it more like 1,150 times 45, you can do that as well. All right, here's your steps. Go ahead and solve using your standard algorithm and see if you can find that correct answer. Go ahead and get to work. let's check in for what we got for our multiplication. When I multiplied using the standard algorithm, I got to an answer of 51,750. Good, looks like a lot of us got there as well, but this is not my final answer. He did not make $51,750, although that would have been nice. So I need to go back and add in my decimal point, just like I did on my last division problem. I noticed that I have 1, 2, 3 digits after that decimal point. Go ahead and put in your decimal point where it needs to go. Excellent. 1, 2, 3. And he did make $51.75. Let's go ahead and find the answer choice that matches that. I don't want to get tricked. I'm not going to pick D, even though I see it has that 0 at the end. I know I can just drop that 0 in my amount of money. We don't usually include that with money. And he did make $51.75. So my correct answer is the letter B. Go ahead and jot that on your paper. And let's move on to question 4. All right, this one you're doing on your own. Go ahead and find some room on your scrap paper. I'm moving up to the top column of mine. Go ahead and set it up. All right, take 20 more seconds. Don't forget to also select the correct multiple choice letter that matches the answer you got. All right, let's check in for number 4. When we multiplied using the standard algorithm, you should have gotten to a final product of 20,150. We then counted the digits after a decimal point. 1, 2, 3, 4. Moved our decimal in our product that many places. 1, 2, 3, 4. Which gave us an answer of 2 and 15 thousandths, which we saw matched answer choice B. Nice work. All right, one more to try together. It is another division problem. All right, question number 5. I am out of room on my scrap paper, so I am going to flip mine over just to the back to find wherever you have space. I'm going to label it as question 5. All right, and now we're looking at a division problem. All right, so here I'm noticing I have decimals in both my dividend and my divisor. I'm going to write this down on my scrap paper. 7 and 56 hundredths divided by. Now, in our last decimal division problem, we tried 2 different ways. One way where we just wrote an equivalent expression and solved, and that gave us immediately our correct answer. We didn't need to add in any more decimal places. And in the second strategy, we kind of ignored the decimals and then added them in at the end. Here, because I want to have a whole number as my divisor, I want to make sure that I'm able to divide like 3 into another number. And so I'm going to try my strategy of creating an equivalent expression. I'm also noticing if I want to turn this number into 3, if I move my decimal point over 2 places right here, I can move my decimal point over 2 places in my dividend as well. Let's go ahead and write our equivalent expression on our scrap paper. So mine looks like this. I chose to write an equivalent expression because I knew I needed a whole number in my divisor right here. And so after moving over my decimal 2 places in my divisor, I moved it over 2 places in my dividend. And so I have an equivalent expression of 756 divided by 3. I can now divide. I won't need to do anything with my decimal point because when I'm done, because I've already created an equivalent expression. These are exactly the same. I know that these two equal each other. This is different from what we did earlier. In this example, just want to make sure we can see it, where I didn't create an equivalent expression. I just kind of pretended that there wasn't a decimal here, and that's why I had to add the decimal back in. All right, go ahead and solve. I'm just going to set up my regular big 7. Go ahead and solve on your own, and then we'll check it. Take another about 10 seconds to finish it up. All right. I got to a quotient of 252. Now remember, I don't need to put in a decimal point because 252 is the quotient to 756 divided by 3. That means it is also the quotient to 7 56 hundredths divided by 3 hundredths because these two are exactly the same. They don't look the same, but they equal the same amount. That's how we know they're equivalent expressions. So there's nothing I need to do with my decimal point. My final answer is 252. Let's check in and make sure that that is a choice. It is a choice. Now I see some tricky choices if anyone got tricked and tried to add in a decimal point, but I know that I don't need to because I created that equivalent expression. So I'm going to jot down that my answer is in fact A. All right. We now have 5 more problems that you guys get to try on your own. We are going to stop periodically to go over them. These are going to be the answers to your independent practice today. So let's set up our scrap paper. Make sure you're labeling this as question number 6. When you get to your independent practice today, it is just going to ask you, what is the answer to question 6? Notice that it doesn't give you any numbers. It doesn't give you the problem because we've already solved them. All you have to do is plug in, was our correct answer A, B, C, or D? So make sure you're taking really great notes right now so you have all of the correct answers for your independent practice today. All right, I have problem 6 set up. All right, go ahead and read it silently to yourself. On your scrap paper, put down whatever is helpful, and then select your correct answer. Go ahead. Good. I see we're not getting tricked. No one is trying to solve this. I looked at my choices already and see it's not asking me for the answer. It's really just asking me for an equivalent expression. So it's a great place for me to just use my process of elimination to start Xing out choices that are not equivalent. So let's take a look at choice A. Here, I'm noticing we moved the decimal one place over in our dividends, but we didn't do anything to the divisor. These are not equivalent. I would have put an X on choice A. On choice B, I'm seeing, we moved the decimal to the left in our dividend and then to the right in our divisor. Well, I know that 2 divided by 68 is not going to be the same as 20 divided by 6. This cannot be equivalent. Let's take a look at choice C. All right, this one's looking pretty good. I see we moved the decimal point 2 places over to turn 20 and 92 hundredths into 2092. But then we only moved the decimal point 1 place over. This one was tricky. If you got tricked, it's okay. If you didn't get tricked, I'm very impressed. This one is not actually equivalent because I moved the decimal 2 times in my dividend, but only 1 time in my divisor, and we know it has to be the same. So now if I take a look at choice D, now we're cooking. I see that in our dividend, we moved the decimal point over 1 place to get to 209 and 2 tenths. And in our divisor, we moved it over 1 time to get to 68. So our correct answer is in fact D. I want to make sure I have this on my scrap paper so I know that question number 6, the answer is D. Because when I get to my independent practice today, all I'm going to have to do for question 6, I'm going to go back to my notes, make sure you save these. Question 6, the answer was D. And I'd be able to select it, and I'm 100% confident I got it correct because we just solved it together. If you had the incorrect answer, perhaps you got a little bit tricked and picked C, that's okay. Go ahead and erase it and make sure on your scrap paper you have the answer D. All right, and now let's take a look at question number 7. All right, question 7, we've got a multiplication question. Go ahead and set it up on your scrap paper and solve. Don't forget the correct letter to go along with it. Ten more seconds and we'll check in. All right, let's see what we got. For question number 7, when we multiplied, we should have gotten to an answer of 7,980. We then counted our decimal points, 1, 2, 3, 4 digits after that decimal point, meaning we need a total of 1, 2, 3, 4 digits after that decimal. After that decimal point. We would then go back and check that with our answers, and that does in fact match answer choice A. So if you got answer choice A, nice work. You got it correct. So when you're doing your independent practice today, you know that the answer to question 7 is A. So all you're going to see is question 7, and you'll know to select A. Should be pretty easy breezy. All right, moving on to question 8. Make sure you have room on your scrap paper. Go ahead and get your problems set up. Think about which strategy you want to use. We did talk about 2 of them for dividing decimals. Think about which one makes the most sense for this problem. Thinking, do I want to create an equivalent expression? Move the decimal the same number of places for each my dividend and my divisor. Sorry about that. All right, let's check in and see what we got for question number 8. All right, so the first thing that I did when solving question number 8 is I created an equivalent expression. So I moved my decimal point over 2 places in my dividend, which gave me 567, and 2 places in my divisor, and that gave me 30. I then thought of this problem as 567 divided by 30. Because I created an equivalent expression, I knew that whatever my answer to this problem was going to be my answer to this original problem, because we already said that these were equivalent, or they are the same. So they should have the exact same answer. So I started off by doing 30 times 10 to get me to 300, then 30 times 7 to take another 210, 30 times 1, and I was left with 27. So I knew my whole number was going to be 18. I knew 30 didn't quite fit into 27, but I did think that, well, if this had just been a 3 times 9 is 27, so I could do 30 times 9/10 to get me to 27. And so when I added up all of my numbers, I got to 18 and 9/10. I don't need to move my decimal, because if my answer to 567 divided by 30 is 18 and 9/10, my answer to this equivalent expression is going to be exactly the same. This is how I got to the answer of C. If you also got C, nice work. This one was tricky. Let's do an air high five. Get ready. Shh. If you didn't get C, please fix it now so you have that correct answer, so you know when you go to take your independent practice and you get to question 8, you just know immediately that that answer is C. You should already have that written down. All right, scholars, 2 more to go. Let's move on to question 9. All right, there you go. Go ahead and set this one up. Don't get tricked with your equivalent expression. Okay, let's check in and see what you got for your equivalent expression. I see a lot of us did not get tricked. We noticed that in order to make our divisor a whole number, we actually had to move that decimal point 1, 2, 3 places, which means in our dividend, we had to move it 1, 2, 3 places, which means we got an equivalent expression of 145,000 divided by 1, because we moved our decimal point 1, 2, 3 places over in our dividend. So, in our divisor. So 1, 2, 3 places over in our dividend, which means we're just doing 145,430 divided by 1. The great news is I don't need to set up a big 7 to divide by 1. I know anything divided by 1 is just itself, which gave me the answer of D. If I'm just dividing, if I had $145,430 that I'm just sharing with one person, well, guess what? That one person gets all of it. And so this got me to the answer of D. Make sure you write that down so that when you're doing your independent practice and you get to question 9, you can just quickly and correctly select that the answer is D. All right, last one for today. Question number 10. Go ahead and read it silently to yourself. Set up your paper. Think about what operation you're doing, what number sentence matches this story. Always a great idea to use some estimation, especially when you have multiple choice like this. All right, just a quick check-in with what we have set up so far. I'm already thinking of two different ways I could solve this, just depending on which one I prefer. Since I already have a whole number in my divisor, I can just kind of ignore the decimal for right now and think of this as, okay, how many times does 4 go into 7,492? The one thing is I will have to remember, I'm just going to put a star there to remind myself, I will have to remember to put the decimal point back in when I get to my final answer because I took it out. Now, the other way of thinking about this is with my equivalent expression. I could think of this problem as how many times does 400 go into 7,492? Here, whatever I get as my final quotient, I don't need to adjust the decimal point because I already have an equivalent expression. Whichever one you prefer, go ahead and try. Go ahead and finish up solving this question. All right, let's take a look at two different possible strategies. So the first way I thought of it was, and check yours, this is what you did along with me, I just thought of it as 7,492 divided by 4, and I know I'll need to add my decimal point back in. I was able to multiply it by 1,873. It worked out perfectly, and I got to an answer or a quotient of 1,873. Now, I know this is not really my final answer. First of all, if I estimate $75 divided by 4, she's not spending $1,873 on each of her friends. I also remember that because I took out that decimal point, I need to now add it back in 1, 2 places. So I get a final answer of $18.73. Now, the other strategy that some of us were using is we went ahead and created an equivalent expression and thought of it as, okay, 400 going into 7,492 multiplied by 10 by 8. At this point, I was left with less than 400. So I needed something smaller than 1. Here I thought about, okay, well, 4 times 7 is 28. So 400 times 7 tenths would be 280 thousandths. After dividing and adding up all of my amounts, I got to an answer of 18 and 73 hundredths, or $18.73. Same thing, here I didn't need to move in the decimal point because I already had it factored in right here, whereas in this way I did. It's really up to you which strategy you want to use. But whichever strategy you use, if you got $18.73, nice work. Make sure you've jotted down which multiple choice answer that matches so you have that. So that when you go to do your independent practice today, everyone should be getting a 100%. You are just going back to your notes, starting with question number 6. What was our answer for question 6? That's right. I'm just going to click it. Should be easy breezy, and I should see nothing but 100s today. All right, scholars. Nice work. Tomorrow, you're going to have more to try completely on your own. Your independent practice will look a little bit more like it usually does, where you're solving all on your own. Today was just some work together, so excited to see all these fantastic 100%. Thanks for doing all the math along with me, and I will see you tomorrow.